Hello, it's Friday. It is February 15th, and welcome to Algebra 2. All right, Unit 1, Lesson 11. Algebra 2, Unit 1, Lesson 11. Your learning target today is you should be able to say, I can compose different functions into a larger function. You can compose simple functions together. All right, so what we're going to basically do is take functions that we're somewhat confident with, somewhat familiar with, and we're going to smash them together today. All right, so to kind of illustrate this idea, a function is like a mathematical input-output machine. The function, for the x is the input, you put the x into the function, and then it spits out an output, an f of x. It spits out a y. For whatever x is, then there's a y. So here's an illustration of a different kind, same kind of idea here. All right. So this is Frank's Fun Factory, and we got apples going in to Frank's Fun Factory, and then after the apples go into machine 1, they come out to be lemons. That's what's happening. Apples are going in, lemons are coming out, just like a function. X's go in, f of x's or y's come out. So the apples go into machine 1 and lemons come out. Then the lemons they get put into machine 2. And then after the lemons go into machine 2, oranges come out. All right, and the first question I want you to ask or answer is I want you to describe what happens then in Frank's Fun Factory. And then after you get done with that, I want you to answer the question, let's assume that Frank's Fun Factory here is being sold on TV. Would you want to buy it? Would you want to buy Frank's Fun Factory? If yes, explain why. If no, explain why. Either way, I want you to explain why. Pause the video here, finish this page, and we'll move on. I make funny faces as I wait for you to unpause the video. Okay. All right, we're going to compose some functions. We're going to hit our learning target early on, right? We're going to start out easy. And then we're going to get a little bit more difficult. So here's how it works. This is one way to express a composition of functions. We've got the f of negative 1 of g. Okay? So we're going to compose these two functions together. And what you do with this is if you see this written here, you're going to first look at this piece here. If the x is negative 1, if the f of negative 1, if you plug that into the f of x, what do you get as an output? So let's look. I got my two functions. Here are my two functions. My f of x is 2x minus 1. My g of x is over here. That's going to equal x squared plus 4. All right, so I've got this g of f of negative 1. So f of negative 1, let's do this. We've done this before. This is called evaluating an expression. We're going to evaluate it. We're going to plug negative 1 into the f of x. Negative 1, so 2 times negative 1 minus 1. So you see what I did there? I just plugged negative 1 in for x and wrote that function out. 2 times negative 1 is negative 2. Negative 2 minus 1 is negative 3, like we have right here. So now that we have an output out of the first machine, we need to put that into the next machine. Like the apples became lemons. Now we got lemons. Now we got to go put the lemons into the next machine to get the oranges. G of negative 3. The g of negative 3. So we got to plug negative 3 into our g of x function. So here the g of x function is x squared plus 4. So I got to plug in negative 3 for x. So negative 3 is going to get squared, just like the x got squared, plus 4. So what's this equal? Well, negative 3 times negative 3. A negative times negative is a positive. Negative 3 times negative 3 is positive 9. Positive 9 plus 4. Break out your calculator if you don't know it. That's 13. That's what we have right there. So we went from the g of f of negative 1. We plug negative 1 into f of x. We get negative 3. We plug negative 3 into the g of x. We get 13. So the g of f of negative 1 is 13. All right? Take a deep breath. Whew, wasn't so bad, right? Let's try another one. This is the f of g of negative 1. So it's like the reverse of what we just did above. This time we're going to plug negative 1 into g. All right, well, remember what g is. That's x squared plus 4. Well, if negative 1 is x, then we have to square negative 1 plus 4. Negative 1 times negative 1 is positive 1. Negative times a negative is a positive. Negative 1 times itself. Negative 1 squared is positive 1. Positive 1 plus 4 is 5, just like we have here. You feeling this? Now what do? I got to plug 5 into my f of x. So it's 2 times 5, instead of the x, minus 1. 2 times 5 is 10. Use your calculator if you don't know these things. And then 10 minus 1 is 9, just like we have here. And use your calculator, use your tools. You know, you don't have to do it in your head. I'm doing it in my head because it's easy for me. But, if you're still building up those math facts, that's okay. Use those tools. And remember, in the back of the classroom, I got scrap sheets of paper with the multiplication tables to help you remember your math facts. Okay, all right, next one. Again, this one's done for us. We're just kind of following the logic here. I want you to get used to the line of thinking. We're putting the number into one function, which then gives us an output, which we then plug into another function, which gives us yet another output. All right? Sorry, I was doing body language off camera. That doesn't help you at all, does it? So the g of f of 3. So I'm going to plug 3 into my f of x first. All right? The f of 3. Well, 2 times 3 minus 1. That's the f of 3. 2 times 3 is 6. 6 minus 1 is 5. I plug 5 now into my g of x. 5 squared plus 4. 5 squared is 25. That's 5 times 5. 25 plus 4 is 29. You feeling this? Okay, now we have a blank here. We got to fill this in. We're looking for a pattern. How do I know? Pause the video here. Think about what you'd want to put in that box. All right, if you've unpaused the video now, hopefully you've seen the pattern. It's whatever's over here kind of goes in the next box. We're going to put the g of 3. All right, did you see that pattern? If you did, cool. Good observation. If you didn't, that's all right. You're learning. You just learned something new. Look at that. We learn from our mistakes. We learn from thinking, asking ourselves questions. Questions are a learning tool. All right, the g of 3. So we plug 3 into our g of x. So it's going to be 3 squared plus 4. 3 squared is 9. 9 plus 4 is 13, right? 13. Now we got to plug 13 in the f of x. All right, so 2 times 13 minus 1. 2 times 13 is 26. 26 minus 1 is 25. All right, 25. We did it. We got there. Let's do the next one. I got the g of f of 6. The first step is the f of 6. What's the f of 6? Well, it's going to be 2 times 6 instead of x minus 1. I just plugged the 6 in for the x up here. 2 times 6 is 12. 12 minus 1 is 13. So what do I put here? Pause the video. Think about it. What do you put here? You're going to put the g of 13. Oh, no, wait. Whoa, Mr. Salt, back that up. Back that up. 2 times 6 is 12. 12 minus 1. 12 minus 1, Mr. Salt, that's 11. The g of 11. What was I thinking there? Why did I say 13? I don't know. You know, that's a key to slow down your thinking. Don't go too fast. Going fast means making silly little errors, all right? So let's think here. The g of 11. The g of 11 is going to be 11 squared plus 4. Again, you might not know what 11 times 11 is. It's one of those basic math facts on the multiplication table. It's 121. If you don't know that, use your calculator. That's okay. You don't have to have it memorized if you use your tools. If you use your tools, you don't have to have it memorized. If you want to move really fast, having it memorized helps you move a little faster. But again, moving fast makes mistakes, as we just learned. So 11 squared. 11 squared is 121. 121 plus 4 is 125. We did it. We got there. Woo! All right. This next one, it's a little funky. It's a little funky because we don't do this very often. We don't see this very often. But we have the f of g of the square root of 3. I'm going to say that again. The f of g of the square root of 3. G of the square root of 3. Well, I got to plug the square root of 3 in for x at my g of x. So let me show you how to do this. The square root of 3 is now going to become squared plus 4. All right. What do we do with this? Does anybody know? How do we interpret this? Well, the square root. What is the square root of? It means I'm looking for a number times itself that will give me so the square root of 4 is 2, right? Because 2 times 2 is 4. The square root of 64 is 8 because 8 times 8. So when I say square root, I'm saying I'm looking for a number. If I times it by itself, will give me the number inside that square root function. Squared. What squared means? It means I'm going to take a number and I'm going to multiply it by itself. So these operations are inverse. They're opposite things. They mean exactly the opposite thing that the other one does. So these functions, because they're inverse, they cancel each other. This squared cancels this square root. All right? So all I'm left with is 3. Hopefully that feels good right there, okay? And what I'm left with is 3 plus 4. 3 plus 4 is 7. All right? So now we've untangled this a bit. What we have now is the f of 7. We got to plug the f of 7 in. 2 times 7 minus 1. 2 times 7 is 14. 14 minus 1 is, say, 13. Right? 2 times 7, 14. 14 minus 1, 13. All right, give me that smiley face reflection in the bottom right-hand corner. Tell me how that feels. Did I confuse you? Frowny face for you're completely confused and lost. Smiley face for Mr. Salt, that's easy. I feel good about this. And the thing in between, which is really what we're looking for most of the time, is that I'm struggling here, but I'm learning. I'm kind of got it, but I need more work on it. That's exactly where you should be. If you're a smiley face all the time, that means it's too easy and I need to make it harder and speed it up. If it's frowny face, I need to slow it down and break it down more, okay? All right, so here's a few of them. Again, I'm going to go, let's remind ourselves, we've got the f of x was equal to 2x minus 1, right? And the g, you tell me if I was wrong, right? G of x equals x squared plus 4. I'm going to have to go back and check. What was the g of x again? Yep. Okay, good. We're all good. My memory served. What a cough. Got to pause the video. Sorry, that bronchitis has still got a little bit of its grips on me. All right, so this time I'm not going to write it down. I'm just going to kind of do it all in my head. If you can't do it in your head, write it down. So let me just kind of break it down to show you how I'm going to do this. These first ones here, and I want you to do these ones. All right. So the g of f of -1. So what I do is I have to break down the f of -1 first. The f of -1, if I plug -1 into the f of x, -1 times 2 is -2. -2 minus 1 is -3. So I have the g of -3 right here. I'm going to plug -3 into my g of x. -3 times -3 is 9. 9 plus 4 is 13. All right? Are we feeling that? We have the f of g of -1 for this next one. So we're going to do the g of -1 first. So we plug -1 into our g of x. -1 times itself, it's going to be positive 1. So that negative times negative is a positive. Positive 1 plus 4 gives us 5. We now plug 5 into the f of x. 5 times 2 is 10. 10 minus 1 is 9. That's our output of this composition of functions. Let's do the next one. The g of f of 3. So I have to do f of 3 first. F of 3 first. Here it is. Plugging 3 into the f of x. 3 times 2 is 6. 6 minus 1 is 5. That's what I've got right here. G of 5. All right, g of 5. I'm going to plug 5 into my g of x. 5 times 5 is 25. 25 plus 4 is 29. Okay? Give these next ones a shot. I'm going to go over them in a second, so don't worry. I'm going to give you the answers, but I want you to pause the video. I want you to try it right now. Pause the video. Give it your best shot. Okay, well, you've unpaused the video because either you got this or you're feeling like, oh, I need you to help. That's okay. That's all right. Either way, we're doing good. The f of g of 2. The g of 2. The g of 2. 2, I'm going to plug 2 into the g of x. 2 times 2 is 4. 4 plus 4 is 8. So I need the f of 8. Because it's now going to get composed into the f of x. The f of 8. 8 times 2 is 16. 16 minus 1 is 15. Look at that. We got it right. The g of f of negative 4. So first step is the f of negative 4. All right, I plug negative 4 into f of x. Negative 4 times 2 is negative 8. Negative 8 minus 1, it gives me the g of negative 9. Negative 8 minus 1 is negative 9. Use your calculator if you don't know. All right, the g of negative 9. Plug negative 9 into my g of x. Negative 9 times negative 9. It's going to be positive 81. Again, use your tools if you don't know. 81 plus 4 is 85. We're doing good. We're doing good. Everything's lining up. Everything's lining up here. All right, this one is hard. This one's hard. If this one stumped you, it's supposed to stump you. I usually try to throw like a challenge question in there sometimes. You've got to like reverse engineer this one. All right, you've got to like undo the composition of functions. Let's see. I start with 4, and I know that first I did f of x. I did f of something, and then I did g of something, right? I know that much just by this piece right here. What I don't know is what got started with. Well, so the g of x is equal to x squared plus 4. What this 4 tells me is that I have already put something into the g of x, and 4 got spit out. 4 was the output. So I'm going to put 4 as the output here. So I have a number squared plus 4 gave me 4. What number, if I square it and I add 4, will give me 4? Pause the video, think about that. What number, if I times it by itself and I add 4 at the end, will give me 4? You're unpause the video now because either you got it or you're stumped. 0. Think about it. And okay, if you didn't know, let's think. We could say minus 4, minus 4. I get 0 equals x squared. What number has to be times itself to get 0? Well, 0 is the only number that it times itself. X equals 0, all right? So 0 times 0 is 0. 0 plus 4 is 4. Okay, so what must have happened here is I must have put 0 in for the g of 0 here. The only way I got 4 spit out from g of x is if the g of 0 got inputted in to give me the output of 4. Okay, well, if I know that 0 got put in here, then I know my output for my f of x was 0. I know that 2x minus 1 had an output of 0. So what number went into the function to give me an output of 0? Is that making sense? To find that out, I have to add 1, add 1. Gives me 1. 2x equals 1. I would have to divide by 2. Divide by 2, x equals 1/2. 1/2 is the number that got put into the f of x that spit out 0. The 0 got then put into the g of x, which spit out 4. And we have just reversed engineered all that. All right? Give me that smiley face reflection in the lower right-hand corner. Tell me how you're feeling about this. Are you completely confused? Are you kind of getting it? Or is this just too easy, Mr. Sold? Make it harder. Come on, Mr. Sold. Give me something I can sink my teeth into, right? Maybe somebody's saying that. Don't worry. Okay. All right. So on this page, I'm going to do 2 of these, 2, and I want you to do the rest. All right. So I'm going to show you 2 more. Check for understanding. I read the check for understanding. We're moving towards independence on those checks for understanding, so that I can actually use them as a measure of how you're doing. Do they really get it? All right, I'm going to do this one here. What other one looks kind of hard? You know, I'm going to do this one here. All right? I'm going to do those two. I'm going to do those two because K is that square root. I'm afraid the square roots will throw some of you off. All right, so this is the K of T of 20. So what do I do first? I need to do the T of 20. The T of 20. What is the T? What is the function of T of X? Well, the T of X is over here. It's 3 plus 1/2 times X. So the T of 20 is going to be 3 plus 1/2 times 20. Well, what's 1/2 times 20? 1/2 times 20 is 10. What's 10 plus 3 is 13. So the T of 20 is 13. All right? Now I got to put 13 in my next function. I got to compose the function. So now I need to find out what is the K of 13. All right? Can you see can you see that there? The K of 13. Well, the K of 13, I got to put 13 in for X, for whatever K is. K is X minus 4, so 13 minus 4. What is 13 minus 4? That's 9. What is the square root of 9? If you don't know, use your tools. Let me show you how to find the square root of 9 on your calculator, if you're not sure. First, you press the blue second button. All right, and then we're looking for the square root symbol. The square root symbol. Whoop, 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 whoop. There it is. Do we see the square root symbol? It's in blue. It's in blue right there. Square root symbol. Put 9 in. I'm pressing enter. 3. 3. 3 times 3 is 9. So the K of T of 20 is 3. The K of T of 20 equals 3. That's how it's done. Step by step. Plug in one thing till you get an output. Plug the output into the new thing till you get another output. That's a composition of functions. We're hitting those learning targets. You can compose different functions into a larger function. The K of 85. The K of 85. Well, K, the G of K of 85. All right, well, first I got to do the K of 85. K of 85 is going to equal the square root of 85 minus 4. 85 minus 4. Well, that's the same thing as the square root of 81. 85 minus 4 is 81. Square root of 81 equals 9. And again, you don't know that. You go to second, square root, 81, press enter, 9, because 9 times 9 is 81. I now got to put 9 into my new function, into the G of X. So the G of 9 is now going to be 9 squared plus 3. Well, 9 squared is 81 plus 3. 81 plus 3 is 84. You could just circle the 84, or you could rewrite it. That's how it's done, folks. All right? Keep doing that. Answer these questions. Pause the video here. Finish up this page. Remember, do your best. You show me some effort, and that's at least developing. If you're giving me something along the lines of what I'm looking for, that's good effort. You'll be happy with that. The rubric's on the bottom of the page. After with a check for understanding, hit me up with that reflection. What's working with the instruction? What's working with you? What's working in the classroom? What's working at home? I don't know. What are the good things? What are the positives? And then how can we tweak things? How can we make things just a little bit better? All right? Give me that reflection. It's part of your grade. Don't skip it. All right, the homework is ridiculously easy. I love these. I don't know. I don't like composing functions particularly. It's okay. But I like composing functions when it's on a table. I don't know. It's kind of fun almost. I know that's kind of weird to say with math, but it's almost kind of fun. All right, I've got the G of F of 3. This is how hard this is, all right? Brace yourselves. A challenge is coming, okay? First, the F of 3. I have to find out that when the f of x function, when x is 3, what is the output? Well, on a table, that's real hard to find. Right there it is. Do you see that? This is the f of x. This is where the f of x, that's where the x is 3, just like what I'm looking for, the f of 3. And I just found out the output was 5. Whoa, it wasn't that hard? I just had to look for a number and find out what the other number was. And now all I got to do is now insert my output for my f of x as my x value for my g of x. So I've got to take this 5 and find out where in the g of x is the g of x 5. Boop, right there. Oh my gosh, how I had to find where 5 was in my x values for my g of x. Oh, that's not scary, hopefully. And then, I got the answer was 8. Boop, 8. That's my answer. So the g of f of 3 is 8. You just kind of like, it goes in one machine, it comes out, it goes into the other machine, I get my answer, right? Sorry about the cough. Apples go in, lemons come out. Now I put the lemons in the next machine and oranges come out. That's the composition of functions. That's all I've got for you. Have a great day.